Hi, welcome to third video in our Arduino series. Like I mentioned before, this series will start from absolute basics to AI-driven robotics. So stay tuned. Spend these few minutes every day. We will have this live streaming every day. So you will have access to it. And by the way, we also have a on-site lab for TechieTalksAI Innovation and Maker Space, where you can come, we mentor, you can come as a parent, a child, or a group of friends if you're doing engineering. All age groups can come and be mentor, and you can build real world projects in our Maker Lab. It is one of its kind, including 3D printing. Okay. We also teach 3D modeling. So coming back to our Arduino series, this time what we are going to do is we are going to introduce an input to our Arduino, because our first episode we worked on the built-in LED, which is an output device. Then we connected an external 3 LED traffic signal, which is also an output device. And now what we are going to do is we are going to connect an input device, which is a switch. And we are making this switch to make the traffic signal work in a manual mode. So if I press now red is blinking, red is on. If I press now, it will, through yellow, it will go to green. And if we press again, yellow will come on, showing the transition, and red will come on. So this is a nice manual traffic signal. So this is what, like I mentioned before, every project will have some practical significance. So before we do that, I'm going to show you different types of switches which are available in the market. Okay, so this is a push switch. Okay, so this is a push switch. Let me see the focusing. Okay. So this one will, when you push, these two pins will get shorted or connected. But you can't use this on a breadboard. See this? You can't put it into a breadboard. So this won't work. This is called SPDT, single pole dual throw. So you can put it down or you can put it up, and accordingly connection will come. Sorry, this is a double pole DPDT, double pole dual throw. Okay. So connection will happen from here to here or here to here. But again, we can't use it in a breadboard without soldering wires to it. This is another push switch, push to on switch, but again, for us, for our DIY projects, this is of no use. But when we build bigger projects, you can fix this on the box and connect wires. So we will also, on our hands-on lab, we do soldering and we can connect this. This is our old push to latch switch. One push, it'll come on, another push, it'll go off, and you can connect wires. Our jumper wire actually can be connected to this switch, and then other end of the wire can be inserted into the breadboard. But again, but this will be hanging loose. which will not be neat. Then this is another good switch for projects, school projects, etc. But again, we need soldering. But you can also cut the jumper wire and attach it on these two edge, and other end of the jumper wire you can connect it to the breadboard, but again it won't look neat when you do that. So I'm just familiarizing you. This is another small switch, push to on switch, and this will work on the breadboard. Okay, this type of switch, if you are buying from the market, this you can push it into the breadboard. Okay, so I'll keep this here. And this is another dual throw switch with the center neutral position. In the neutral position, there won't be any connection from here to this side. Another push to on switch, and this also will work on the breadboard. Okay, we'll keep it here. This is another slide switch. Okay, again cannot be used with the breadboard. Another slide switch. This is for to mount it. When you design your own PCB, you can mount such a switch on the PCB. We also do PCB designing workshops. Okay. Then another very interesting switch is called push to latch. One push, it will latch. Another push, it'll release the latch. And this can also be inserted into the breadboard. Okay. But it is a latching type. We don't need latching type because we are using an Arduino. So Arduino is able to intelligently latch. Okay, another on-off switch. Again, not immediately useful for us for the breadboard. And then we have a push switch with longer pins. So if you use a cutting plier and cut this much, then we can put it on the breadboard. Okay. So for breadboard, these are the switches that we can use. And for this project, we have used this switch. Okay. Push switch. So when you order, look at this picture and order similar switches. So let's see how we can begin using a switch. So what we will do is we will do a simple project where we will first connect the switch and see what it takes to utilize the switch within Arduino. So let's use our red pin. Okay. Okay, let's you define all the LED pins because we can keep the other LEDs off. So here we are defining a new line 5 is a button pin. See this? So this is an input. Okay, pin number 2. So what I've done, I've connected one end of this switch to the ground of the Arduino, other end of this switch, other connection from the switch go into pin 2 of the Arduino. See this? And Now we are defining a variable current state 0. Okay, you can ignore this comment. And last button state high. So, so using an input switch is not that straightforward. You need to understand this logic. We will explain that. Okay. And then let's define in setup. What we will do is we will define the pin mode. All the three LEDs are defined as output, and button pin is defined as input. And do you see this? We have we are defining it as input, but we are also saying pull up. What it means is when the switch is not connected, this is the Arduino's pin 2. Okay. When the switch is not connected, what Arduino will do is Arduino will connect a resistor and connect it to the plus voltage. That is what this does. So when the switch is not connected, 2 will read, 2 input 2 will be read as high. That is what it means. So anytime you connect this, anytime you press the switch, other end of the switch should be connected to ground, and ground we draw like this. Okay. So when you push the switch, this will become low or 0. That is what it means. And we are turning all the other LEDs off. We are only keeping red LED high, but we don't want that. We will also keep the red LED low. Okay, so we will keep this simple for now for our understanding. So now all the LEDs are off. We will read the button state. How do we read the button state? We will see this Boolean means this button state can be 0 or 1, true or false. 0 means false, 1 means true. It can only have two values. Okay, binary. Then digital read button pin. Button pin is pin 2. Okay, so it will read the button 2 state. If the switch is open, it'll be read as high. If it is closed, it will be read as low. So what we can do here is I will use an if condition. If button state is low, what we will do is we will make the red LED on. Otherwise, what we will do, we will switch off the red LED. Okay. So if here one curly bracket is needed. Okay. Let's upload and see. So now when we compile and upload this to Arduino, every time you press the switch, red LED will come on. For such a simple project, you don't even need an Arduino, but this demonstrating how we can make use of a push switch. Okay, so there is an error. Okay, so this curly bracket is extra. Okay. Okay, done uploading. And let's see, all the LEDs are off. If we push, red will come on. So we have used this Arduino board to program this circuit so that it is reading this input pin 2. Whenever it is low, it is turning the LED on. Okay, so now what we'll do is we will copy the code for the traffic signal and understand it's working. Okay, so let's upload this again and confirm that. Okay, done uploading. See, okay, manual traffic signal. So how it is working is these are all same lines, no difference. Okay, so these are our LED pins. Then we have the button pin, which is input. These are all outputs. Okay. Then here we are we are saving current state and we are loading as 0, which is indicating red signal on. And last button state, we are keeping it as high starting. That is, button is not pressed, it is going to be high. We are uh, loading this variable last button state with high. Then the setup is nothing new. Okay, defining the input pin, defining the output pins, and presetting the signal in the correct state. Okay, so yellow and green are off and red is on. Traffic signal is starting with red on. Clear? Let's move up. And this is the loop. Now, before we go to the understand the loop, let's understand these two functions. One is go to green. Okay, and go. What is this go to green doing? It will turn the yellow light also on because red was already on. It will also switch on yellow. And then it'll only switch on yellow, red will go off. And then here, green will come on. So that is going to green through yellow. Now we have similar function go to red. So yellow will come on along with green, then yellow will alone will come on, then red will come on. Okay, so those are the two functions. When you define a line like this, we can call this go to green anywhere in our main loop. That is what is happening here. So let's understand the main loop. Here we are reading the switch. It can be high or low. Then button state, if it is high, and button state, if last button state was high and the current button state is low, we begin changing the signal. Why is this happening is, normally when you don't push the button, this is pin 2, okay, that will be having constant high voltage, okay, and this will be high. And when you push the switch will move like this, and then it will become low. Why is this happening? Because this is a mechanical switch. Mechanical contacts will have some inherent bouncing. So we need to handle this much of bouncing. Depending on the quality of the switch, this bouncing can be high or low. So in order to handle that, we are providing a 200 milliseconds debounce delay. So during this time, the in pin 2 will be high or low, high and low, high and low several times. We don't want to false trigger the signal by reading this value during this period. So we are putting a delay of 200 milliseconds before we read this pin 2 again. That is what this is doing. So if the current state was 0, then we call go to green and switch the current state to green. 1 means green, 0 means red. Else, if else means current state but was not zeros. So then we go to red and set the current state to 0. So this is called toggle or toggling logic, where every push of the switch we toggle the state, flip the state. Clear? Give me your valuable comments. Like this, slowly, step by step, we will learn Arduino. So that is it for this video. Please remember to like, share, and give your valuable comments. And please feel absolutely free to comment what you want to see next, or any doubt or clarification that you want. Come via the comment section. And check out our website shogini.com for more on our maker space and maker lab.